Let's do a couple of examples. These questions are asking us to find the Rx value that will minimize the current that is running through the 2 kilo ohm resistors. So what would minimize this current here? So the minimum that you can get here in the absolute value is 0. And when will this be happening? If this voltage here at node A is equal to the node B. So if VA equals to VB, then Ix absolute value equals to 0. Let's see if it is possible to achieve this. So we're going to say that, okay, we will think that Ix is 0. So what does this mean? If Ix is 0, we don't need to worry about this 2 kilo ohm resistor. So we can treat this like a bridge, like a Wheatstone bridge. So we can draw the circuit again as 10 volts and this is VA here with 4 kilo ohms and 6 kilo ohms. Then we have an equivalent resistor here, which is Rx plus 1 kilo ohm, and then we have 1 kilo ohm VB. Keep in mind that if VA equals to VB, it doesn't matter if we have a resistor in between, or if we have a short, or if we have an open. So in this case, how can we calculate VA? VA is going to be, if we assume that this is our reference, the top is 10 volts. VA turns out to be, it's just a voltage divider. It is 4 kilo ohms divided by 6 kilo ohms plus 4 kilo ohms times 10 volts. That equals to 4 volts. So if this is the case, we can say that VB equals to 4 volts. What does this mean? VB to 10 volt ratio, which is the whole thing here, right, has to be conserved. So we have some current running, let's call this IB. That current is shared. So if VB equals to 4 volts, actually is the same thing as 1 kilo ohm times IB. And the same current is running through here, IB. So in this case, IB is equal to 4 volts divided by 1 kilo ohm equals to 4 milliamps. And IB also relates to the voltage difference between this combination that we have made. So IB times Rx plus 1 kilo ohm equals to the voltage difference across that combination, which is 10 volts minus VB. Here we know what IB is, it's 4 milliamps. Rx plus 1 kilo ohm equals to 10 volts, and we know what VB is, 4 volts. It gets us 6 volts. So Rx plus 1 kilo ohm equals to 6 volts divided by 4 milliamps. That is equal to 1.5 kilo ohms. This means Rx equals to 0.5 kilo ohms. Does this make sense? It is a positive number, and if you plug it back in and recalculate the circuit, you should be able to find VA equals to VB, even with the 2 kilo ohm in the combination. Now look at the second example here. Instead of having a resistor combination on top, we have a current source, which is 2 milliamps. And we are again asking for Rx value, but the Rx now is at the lower part of the circuit. So again, you can think that there's a reference here. The connection up here is 8 volts, this node. This node, you can again call it something like VC. And we can call this